Now I'd like to take a look at the use of regular expressions using the $regex operator in the Node.js driver. Now, regular expressions are handy as a quick and dirty means of searching string-valued fields, such as, say, tag list or overview here, for particular words, phrases, more complicated regular expressions of one kind or another. If you wanted to do something search engine-like, we'd recommend that you use a text index for full text search capability. But in many cases, being able to search text fields using regular expressions is a great way to explore your data and even support some simple use cases in production. Here, we're going to use the $regex operator in a simple application as a means of exploring our data set a little bit. We're going to use the same mechanism we've been working with, supplying command line parameters to our application. Here we're going to look at a very simple application that is only taking a regular expression on the command line. So let's look at our app. So the structure is very similar to the kinds of applications we've been looking at as we are taking our deeper dive into the Node.js driver. If we scroll down, we can see that we're specifying exactly one command line argument. With that command line parameter coming in for a regular expression, we need a way of adding it to our query document. So using this mechanism that we've seen previously, if overview was passed into options, then we're going to set the overview key in our query object to have a value that is this document. And that document has two fields. One has the key $regex with whatever value we specified on the command line as the value of the regular expression. We'll simply specify a string representation of a regular expression there in the command line, and that's what will end up as the value here. We also have a second field here, and that's because I want to ensure that this query is executed in a case-insensitive manner, meaning that a capital A is treated the same as a lowercase a for all characters we match against. So the way I do that is by using the $options operator. And $options is designed to be used with $regex, and I simply specify a lowercase I here. This indicates to MongoDB that I want to do case-insensitive matching. Okay, now one more thing I want to point out about this application is that I've created a projection document function here. We'll be passing in options, and here I'm creating my projection document and returning it. You might wonder why I'm actually checking to see whether there is an overview option, because as we saw when we attempted to run this without a -o, I got my usage message. The reason why I implemented the query document function and the projection document function the way I did is because we're going to extend this a little bit, and in that case it's going to be much simpler if we simply build on to what we have here. What I haven't mentioned yet is exactly what we're going to be searching against in our companies collection as we look for this regular expression. As you might have guessed from the field naming here, we are going to be searching for the regular expression supplied on the command line in the overview field of documents in this collection. Let's run this. And what I'm going to specify as my regular expression is actually just a simple phrase. This is not a class about regular expressions. There's a lot of power in regular expressions, but what I'm trying to demonstrate here is a way that we can simply explore text fields within our collections using the $regex operator. The semantics of this, when it's applied in our query document, are that we will look for this phrase, note that these two words are separated by a single space, anywhere within the text that makes up the value for the overview field for documents in our collection. So let's run it. And if we take a look through the results that we get back, we can see we've got a company called Gross Domestic Product. And here we can see that personal finance appears right here. So again, as I said, our regular expression simply needs to match somewhere in the overview text. Likewise, if we scroll up, we see Mint.com. This is a company you may be familiar with. And we can see that right here, Mint's overview uses the phrase personal finance. That's a simple example of using the regex operator in the Node.js driver. Now let's look at a slightly more complicated example. And here, for this application, we are going to add the ability to search either the overview field or the milestones field. And now our options are -o if we want our regular expression to be matched against the overview field, and -m if we want to match against the milestones field. Now let's just remind ourselves what the milestones field looks like. So going back to our Facebook example, if we scroll down to milestones, we can see that there are actually several text fields. We're reminded that milestones is an array field, and the elements of the array are embedded documents. There are a number of text fields in these milestones documents. The one that we're going to be matching against is this one, the source description here. You can begin to formulate in your head what our query document has to look like. We're going to have to use some dot notation and specify milestones.sourceDescription. Because MongoDB creates keys for all elements in array valued fields when it stores documents, we can use a very simple dot notation expression, milestones.sourceDescription. source description in order to match our regular expression using the $regex operator. So now let's look at how we've implemented that. So as I mentioned, we're going to extend our query document function, and we're also going to extend our projection document function. All right, so let's look at the query document one first. We've set up our command line parameters so that I can specify one or the other or both. The example we'll look at here is simply searching against milestones as an alternative to overview. As we specified before, this is where we specify the value of the overview key in our query document. To do something similar for milestones, we need to use this array indexing syntax because we're using dot notation here. So we enclose milestones.source_description in double quotes. This stipulates that for our query object, we want to set the value for a key defined as milestones.source_description. And then we set the value using the $regex operator here. We're using the regular expression that was passed in as the value for our milestones command line argument. And again, specifying that we want to do a case insensitive match. Based on the discussion in earlier lessons, where we went into this type of setup in greater detail, it should be clear to you what's going on here. Now, I want to point out that we're performing something that's analogous to what we did in the query document function here in the projection document function. If you'll remember from our previous implementation, the implementation for the projection document function in the application we looked at the beginning of this lesson, we simply built an object here using JavaScript object notation and handed that back as our projection document. In this application, because it's possible to have an overview field or a milestones field or both, we have to check to see whether overview is in the command line options it was passed in. And if it is, then we want to make sure that we're including that field in the values that we project out. Likewise with milestones, if milestones was specified in our command line options, then we want to make sure that the milestones.source_description field is included in documents that are returned from the database. Looking at the main body of the application, there's nothing different here from the applications that we've been looking at, with one exception, and that is now we're calling a projection document function to build up the projection document that we then send to the project cursor method. So let's run this app. Here what I want to look for, again, remember the milestones, which are important moments in the history of a company, is the following regular expression. Note that I'm enclosing this regular expression in quotes, as I did when we looked for personal finance. And here, I want to look for two words in succession, but they might be separated by a couple of other words. So the two words I'm interested in are billion and valuation, but it's unlikely that this phrase will appear. I might see $1 billion valuation. I might see a number of ways of expressing this notion of a company having a valuation that's measured in billions of dollars, or some other currency. Using some regular expression syntax, I can specify that I want to see the word billion, followed at some point in the text by the word valuation. In between, there can be any number of characters. And in fact, to be more precise, since this would actually match this expression, I should really say dot plus, which means there must be at least one character separating the word billion from the word valuation, for example, a space character. Again, this is a very coarse-grained means of searching within text fields, but a very powerful and handy tool to have when we're exploring collections. Again, remember that milestones is an array, and so there are many documents within that array that contain a source description field. And in matching against that field, I only need to find one document that matches my regular expression. For each document returned to me, here's Square, founded in 2009. Here are all the milestones that were listed. Here we have the word billion. Again, remember I'm doing case insensitive search, separated by space, dollar space, and then valuation. So here is at least one place where the document for Square matched my query. And now Airbnb. This is kind of an interesting example of a match. It's not something I would have imagined, but certainly makes sense. So here I've got the word billion separated from the word valuation by a plus character and a space. And then for Living Social here, a very simple match where I've got billion, space, valuation. So you can see the variety of different types of matches that this regular expression can have. And this hints at the real power and value of the $regex operator and the kinds of things that we can do with it. If you're interested, I encourage you to take a look at a regular expression tutorial, any of a variety of regular expression tutorials available online. A little Googling will get you where you need to be. MongoDB supports Perl-compatible regular expressions. The Perl programming language kind of defines the standard for regular expressions because they are first-class entities in that language. And MongoDB supports the syntax and operations for those regular expressions.